Hello, this video is for IXL Activity A1.A.6 and it's titled Square Roots. The 3-character code for this activity is 7 Papa Zulu. Alright, square roots. What are square roots? So I have some graphics here to help us out on this discussion. The question says, what is plus or minus square root of 25? We'll deal with that plus or minus symbol in a moment. So let's consider the idea of this portion of it, this square root of 25, this little nifty little sign that we use here called the radical symbol, right? And underneath it is a number. So that number is what we had to consider of what is the square root of that number. So let's first talk about the idea of square roots. Well, one thing we know about squares, I have a square over here on the right with 25 units in it. One thing that we know about squares are that squares have 4 sides, and all 4 of those sides are indeed the same length. So let's consider the square here that has 25 units in it, which probably is the one I selected because we're asking for the square root of 25, right? So I have 25 units inside of a square, and we can see that indeed each side of the square, 1, 2, 3, 4, 5, is 5 units long. If we look at the other side, we'll look at the side over here, 1, 2, 3, 4, 5. So it's 5 units wide, 5 units tall. So the root of a square is the length of one side, kind of like if you think of the base of it here, the roots, the base of the square, like the base of a tree, the root concept. So the base is 5 units long, so a square that has 25 units in it would have a root, or the square root, of 5. So in this case, and I'm going to put 5 over here for now. Why am I not putting it over there? We'll discuss that in a moment. The next thing to talk about is the idea of perfect squares. That's why I have this little graphic here in the bottom middle. So what is a perfect square? Well, a perfect square is a product of 2 equal integers. Integers, remember, are non-decimal numbers. So if you have a square and the length of its side is equal to a non-decimal number, that is to say that it's an integer, then we say that it is a perfect square. Perfect because it's an integer. It doesn't have a decimal value to it. Some examples are 2 times 2 is 4, so the square root of 4 is 2. Right? 2 squared is 4, so the square root of 4 is 2. 3 times 3 is 9, so the square root of 9 is 3. 6 times 6 is 36, so the square root of 36 is 6. These are known as perfect squares because whenever we arrange them with however many units, like 36, if we did a square with 36 units in it, and it truly was a square, then the length of one side would have a value of 6. In my other graphic over here to the left, I've given a list of the first 20 perfect squares. We know it's the first 20 because at the bottom we see 20 times 20. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, and we go on and on. So the first 20 perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, etc. I want to give you a hint. A graphic like this would be really helpful for this activity. Now the next question you might be asking is, well, if the square root's 5, why is there a block for 2 different answers? Well, that's where the plus minus comes in. Because remember that in math we have a positive times a positive equals a positive, right? But also we have a negative times negative equals positive. So this means that not only could we do 5 times 5 to get 25, but we could also do negative 5 times negative 5 would also equal 25. So with that said, we now realize that there are 2 roots to a number. One's positive, the other one's negative, because multiplying negative times negative gives us a positive. So if someone asks me, give me 2 numbers you could multiply to give me a value that you could multiply times itself that you would get 25. Well, most people say, oh, that'd be 5. There's another answer. That answer is also negative 5. Is it not true? Negative 5 times negative 5 equals a positive 25. So also another thing to note is that in this activity we will not see any negative numbers underneath the radical symbol here. They'll all be positive, because if you try to get the square root of a negative number, you're going to need an imaginary number. And imaginary numbers are something that we're not messing with today. So all these values that you see under the radical symbol will indeed be positive. Remember, there is a negative form of the answer and a positive form of the answer as well. So quick review before we move on, and you can always rewind and go back and look at this, or you could even Google a graphic of this. Just type in list of perfect squares or perfect squares and do a image search on it, and you'll find a whole lot of graphics that are going to list the perfect squares for you. Make a copy of them, save them on your desktop, and you'll have a nice easy reference to use. All right, so we covered a few things. What is a square root? Over here, we know that a square root is the length of the side of the square based on however many units that we're talking about, which would be the value that's underneath the radical symbol. And the next thing we talked about, what are perfect squares? These are squares that have square roots that are going to be integers, non-decimal numbers. And then we also talked about a list of those perfect squares is kind of a guide there. So let's look at our next question. Here, what is the positive root of 16? So let's go ahead and look at that. Square root, positive square root of 16. So square root of 16. Now they want the positive one, so that's why there's only one answer here. Only one block to put an answer in, because even though there is a positive and a negative form of it, we're only going to use the positive form of it. So the question is, what number multiplied times itself is going to give us 16? Well, that would be -4. Or it could also be a +4. Two answers to it. But they want the positive one, so we're going to put in the +4. Now you can use a calculator for this. So let me grab my calculator. So on the calculator button, you're going to have to find the square root sign, because we're going to want to tell it to take the square root of a number. Now if you have a cell phone calculator, your cell phone calculator might do this. You can probably find the square root button on that. But what I have here is a copy of it's a computer version of a TI-84 graphing calculator. And notice that there is a second button up here, this blue button that you see me moving the mouse around by. This is like a shift button on your keyboard. So on your keyboard, we hit shift, and also a function button, right? If you want to use something, if you look at a keyboard, above the keyboard has other things, like if you want to use if you look at your keyboard and you see you want to use a left parentheses, well, that's above the 9, right? So you have to hit shift and then hit 9 while holding down shift. So this works the same way. The second button, notice that it's blue. On other calculators, it might be a different color. However, it will match up with the color of the stuff that it represents. What does the second key represent? Well, if you look above all the other keys on the calculator here, you'll see these blue images here: test, angle, draw, distribution, matrix. These are all trig functions here: sine, cosine, tangent, and the inverses of them, pi. And looky here, we got a square root symbol. So if I hit second and hit square root, then it's going to put in a square root symbol, and then it's going to tell me what number do you want to take the square root of. So then I'm going to just type in 16. Type in 1/6 and the square root of 16 and hit enter, and it's going to give me 4. Now it's not going to tell me -4 as well. I should just understand that -4 would also work. Calculator is only going to give you the positive answer, positive root of that value that you're taking the square root of. All right, so with that said, let's go ahead and move on. On the next one, what is the opposite or negative square root of 3600? So we know our answer is going to be negative, so let's go ahead and just put that negative sign in there. Now 3600, let's think about this. Notice that 36 is one of our perfect squares, right? But we got these other two zeros we got to deal with. Well, let's kind of do away with the idea of the negative sign. We took care of that for now. Let's just look at the square root of 3600. So what if I had the square root of, let me see, 3600, I could rewrite as 36 times 100, right? Wouldn't that still be 3600? I think so. So if I took the square root of 36 and the square root of 100, I wonder if that would work. So let's go with the square root of, let's do this equal to, let's say we're going to take the square root of 36, and we're also going to take the square root of 100, and the square root of 36. Well, 36 is a perfect square. 6 times 6 is 36. It's going to be 6. And the square root of 100 is 10, right? And now, remember that this is multiplication underneath the radical symbol here. So I still need this is multiplication here, which means this is multiplication here. And 6 times 10 is 60. So my answer should be negative 60. So let's take the calculator. We're going to take the graphing calculator, and we're going to take the square root of 3600 and see what we come up with. So grab that calculator there, and let's go ahead and clear it out. Let's go ahead and clear our number history here. Yep. Yes, I want to clear all the history. Great. So with that, let's go second key, radical symbol, and we're going to take the square root of 3600. And if I'm right, we should get 60, right? And indeed, there it is. The answer is 60. So we are correct on that. So what does this imply? This implies that, and this is going to come in handy in other lessons as we start to work with radicals, that you can take a value that's underneath the radical symbol and you can pull it apart into multiples that are easier to deal with. So here we took 3600 and turned it into 36 times 100, and then we kind of pulled it apart and put that 36 under a radical symbol and the 100 under a radical symbol, realizing that it's multiplication. Then we simplified those by taking the square roots of 36 and the square root of 100. Then we just multiply them back together to get to our final answer. This is something that you're going to see later on, so be sure to kind of remember that concept. The next one, what is the negative square root? So it needs to be negative. What is negative square root of 100? So we need a negative. So we want the opposite of the square root. Opposite, negative, kind of the same word, right? So the square root of negative 100, well, that would be negative, right? And some number times itself is 100. Well, 100 is a perfect square. And so that answer to that is 10. You could always check that out on a calculator if you want. What is the positive square root of 81? So we want the positive square root. No need to type in a plus sign here. If you enter in a value without a plus sign in front of it, IXL is going to realize that it is indeed a positive number. So square root of 81. Well, that's another perfect square, and 9 times 9 is 81, right? So the positive square root of that is 9. And just for practice sake, let's go ahead and look at the calculator again. And if we did square root, how do we get square root? Hit that second key and hit that x squared button right here that you see the square root above. That puts in our square root sign, and let's do 81 and hit enter, and indeed you can see that our answer is 9. All right, moving along to the next one. Oh, wow. Look at here. We've got what is the positive square root of a fraction? 16 over 64. So it is positive. So, we're dealing with positive. So our answer is going to be positive. Now let's deal with the other portion of it. Square root of 16 over 64. So let's go ahead and do square root of, and let's do 16 divided by 64. Remember, every fraction is a division problem. So let's try that. Let's turn it into a decimal. We know it'll have a value less than 1 because it's a proper fraction, right? Numerators has a lower value than the denominator. So let me grab my calculator here, and we'll pull that up, and let's go ahead and clear this out. Get us a clear board, and let's do the square root. Or wait, no, first we're going to do the 16 divided by 64. So 16 divided by 64. And that gives us 0.25. So let's go ahead and put that in there over here. 0.25. So what if we took the square root of 0.25? What do we get? Let's go ahead and look again at the calculator. We already have the 0.25 in there, so we can use this nifty little answer. We don't have to retype the 0.25. So we'll look at how to do that. So we want the square root of that answer. So we're going to do the square root, second key, square root, and we want square root of our answer. Well, notice down here in blue, down here the negative sign, down by the enter at the bottom, that on this key just above it, it says ANS. That's for answer. So we're going to hit the second key because it's blue. and it's telling the calculator, take the square root of the answer, and the answer is the previous entry that we see right here. Hit enter, and it's going to give us 0.5. So let's go ahead and put that 0, click off of there. There we go. So square root of, oh wait, no. Go back. That's not what we want. We had the answer, right? Final answer, 0.5. So can we just put 0.5 in here? Well, let's look at the instructions. This is where we talk about make sure that you pay close attention to the instructions. This is a correct value. We know that. We did the work for it. We know it's a correct value, but is it in the proper form? Write your answer as a proper fraction, and proper fraction are a whole number. Does 0.5 fall into those categories? Indeed, it is none of these. It has to be a proper fraction, improper fraction, or indeed a whole number. So how do we do this? Well, if we note this, that, 0.5 is a fraction, that's 1/2. So the answer is 1/2. So instead we change that to 1/2. However, there's an easier way to do this. And let's go ahead and look at that. So I'm going to go ahead and erase all this here. We know that we get the answer of 1/2. So let's try something else. Instead of dividing this out and then taking the square root of whatever decimal number that this fraction turns into, let's try something else. Let's try the square root of the numerator over the square root of the denominator. So square root 64, or square root 16 over square root 64. Now what do you notice about 16 and 64? They're perfect squares. So square root of 16 is 4. Square root of 64 is 8. And 4/8 simplifies to, that's correct, 1/2. A little bit easier that way, right? So here's another rule that we see showing up that we've just kind of proven in a way, is that you can take the square root of a fraction and split that and kind of like distribute that square root symbol to both the numerator and the denominator and deal with them is in their own way, as a numerator and as a denominator, which is going to be a lot easier than doing it the other way, like we did the first time. So let's look at the next problem. What is the opposite or the negative form of the square root of 49/4? So we know that we are going to have a negative answer. Again, it has to be a proper fraction, improper fraction, or a whole number. So chances are we want to go ahead and do that, distribute that symbol, that radical symbol, to both the numerator and the denominator. And I'm noticing that the numerator and the denominator are both perfect squares, aren't they? So let's go ahead. We got the negative part taken care of already. Let's just go ahead and always good to rewrite the problem. Make a taller one so I can fit it all in there. Square root 49/4. And now let's distribute that radical symbol to both the numerator and the denominator. So square root 49 over square root 4. 49 and 4 are both perfect squares. 7 times 7 is 49. And 2 times 2 is 4. So the square root of 4 is 2. And we now have 7/2, which that is a fraction, and it is a improper fraction. So this is our answer here. So 7/2. Don't want to forget that negative symbol whenever you type it in. Yeah, it could be real easy to remember, okay, it's negative, I'm going to deal with just this portion of it, and then just put in 7/2 and forget to put that negative sign in. Even though you were correct, IXL is going to count it incorrect because they want to know what is the opposite of square root 49/4. On the next one, what is the plus or minus square root? So we're going to have a negative root here and a positive root. Now this is a decimal. And you're thinking, well, what if it were 9? If it were just 9, if it were just the square root of 9, square root of 9 equals 3. But it's not 9. It's like 9 with 2 decimal places. But what do we know about this? So if we can take this 3 and give it a decimal place, what if instead we considered 0.3? So what is 0.3 times 0.3? Well, if we go ahead and stack those up, 0.3 times 0.3, and we do the traditional algorithm of multiplying those, 3 times 3 is 9, 3 times 3 is 0, 0, so we just end up with 9. And here we have 1 decimal place. Here we have 1 decimal place. 1 plus 1 is 2, so we need 2 decimal places. So taking the number 9 and writing 2 decimal places, 0.8 and then we need a 9 here, place holding 0. Voila, looky what we have here. We have the exact number that we were considering underneath the radical symbol there, called a radicand. So, and after a long pause, I forgot what I was saying. So, yes, indeed, the number underneath the radical symbol is called the radicand. So, we ended up, after multiplying 0.3 times 0.3, we indeed get the radicand. So we know that 0.3 is indeed the square root of 0.09. And so a shortcut for that is to kind of consider it, what if the decimals weren't there? Consider the number there, the radicand, the number underneath the radical symbol. And so in this case it was a 9, so I'm thinking, hey, 3 would work, but I need 2 decimal places. So if I make the 3 my square root, if I go ahead and make that a 1 decimal number, then that's going to require 2 decimal places, and sure enough, that works out. So we got another problem that's similar to that here. Our radicand, the number underneath the radical symbol, is 0.25, like the way I'm working in that academic vocabulary there. The actual symbol itself is called the radical symbol. The number underneath is called the radicand, and together they make a radical. Interesting, right? So with that said, I've got 25, so I'm going to just consider the square root of 25. And I know that that is 5, right? But I'm not wondering about the square root of 25. I'm wondering about the square root of 0.25. So I realize I need 2 decimal places. So what if I just did 0.5? That would give me, right, again, the same deal. If I multiply 0.5 times itself, I'm going to end up with 25. And I have 1 decimal place, and again I have 1 decimal place. Add those together. 1 plus 1 is 2, so I need 2 decimal places. So I throw the decimal there, right? And sure enough, I end up with the radicand of 0.25 again. So I realize that it's going to be a negative 0.5 and also a positive 0.5. Now I could go ahead and use the calculator for these. Again, good practice to remember where that division or where that radical symbol is at on our graphing calculator. So let's go ahead and do the square root of 0.09 and hit enter. And sure enough, we get 0.3. And again, if we go ahead and do the square root of 0.25, don't have to put that 0 in there, it'll still get the same thing. And we end up with 0.5 there, remembering that there is a positive and a negative version of it. On the next one, what is the square root of 2.25? Well, 2.25, think 225 is a perfect square, right? So the square root of 225, and if I recall correctly, is that 15? Now I could go back and check that graphic organizer that I had at the beginning, or I could go ahead and use my calculator. Now I'm thinking it's 15 squared. So if I go 15, type in 15, and then right where that radical symbol's at, where we hit the second key and then that, notice that that is x squared. So I can just tell it to take 15, square it, and let's see, do I get 225? Indeed I do. So it is indeed 15. So that's one way for me to check. I was pretty sure it's 15. Square root of 225 is 15. But I don't need 225. It's not my radicand. My radicand is 2.25. So in this case, I know I need 2 decimal places. So what if I just go ahead and put the decimal there, get 1 decimal place here. That means I'm going to take 1.5. Instead of 15 times 15, I'm going to do 1.5. Same numbers, just decimals been moved over 1 place. So 15 times 15 we know is 225. We saw that on the calculator already. But I have 1 decimal place here, 1 decimal place here. That's going to be 2 decimal places, so move it over 2 places. How you like them sound effects? So 2.25, and indeed, that is my radicand right there, 2.25, the number that is underneath the radical symbol. And what did I multiply to get it? 1.5. So here they're not saying positive or negative. If they only give you one answer block, then they want the positive form of it. So that's going to be 1.5. What are the positive and negative squares of 100 or 1.44? So they do want the negative and the positive. Square root of 1.44. Here we go again. if this were, let's consider the square root of 144 instead of 1.44, we would realize, oh, 12 times 12 is 144. That's one of our perfect squares. 144 is a perfect square in which the root is 12. But we have two decimal places. So let's go ahead and give this 12 decimal place 1.2, and then if we have 1.2 times 1.2, we're going to get 144 and two decimal places. So we end up with the radicand of, end up with the product of 1.44 by multiplying 1.2 times 1.2, which is indeed the radicand of our question that's being asked. So the answer is going to be the 1.2. 1.2 and a positive 1.2. So looking at our next problem here, we see which two integers is the negative or the opposite of square root of 21 between. Finally we don't have a perfect square. 21 is not a perfect square, right? It's not on our perfect square list. And they're asking us which two integers would this value be between. So first let's find the value of the answer here. So the first thing I want to do is I'm going to kind of disregard the negative sign for now. For now, I'm just going to look at the square root of 21 and try to figure out where would that fall on a number line. So I'm going to need a number line. And I'm going to give that number line some tick marks. So we'll put one there, squeeze some in along here, and get this number line built. So it might be helpful for us. And I'm going to give it some values. So it looks like my lowest value is 3, my greatest value is 8. So let's start at 3 and see if we can fit it all in there. 3, 4, 5, 6, 7, 8. Good deal. Got it all in there. Now the next thing is, let's square these numbers on the number line. We got those numbers from the possible answers here. So we're going to square these numbers and find out what the squares of each of these numbers are. So 3 times 3 is 9. So 4 times 4 is 16. 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, and 8 times 8 is 64. So the next question is, where would 21 fall between all of these values up here that we have when we squared them? Because, right, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. So we know that somewhere along here, if we place this number 21, which should fall in between 16 and 25, so someplace in between here would be 21. So if the square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, square root of 36 is 6, square root of 49 is 7, and the square root of 64 is 8, then that means that the square root of 21 falls someplace in between 4 and 5. However, remember, if this were positive up here, we would be looking for somewhere between 4 and 5. But remember, it's asking us for the opposite of that. So we should then picture a number line that is just the opposite, in which we have, go ahead and try to reproduce this, get that in there. And now, since it's opposite, we're going to put 3 down here, and this is going to be negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. And this works out because those are our choices, our answers, correct? So the next thing we're going to do is realize that if we're between 4 and 5 on the positive side, then we're going to be between the negative 4 and the negative 5 on the negative side as well. So the opposite of square root 21 is going to fall someplace between negative 4 and negative 5. And the reason that they say negative 5, negative 4 is because they're just like if we said between 3 and 4. Notice that 3 is less than 4, so we would list that first. They're saying between negative 5 and 4 because negative 5 is less than negative 4. So this is the reason why we see this right here. So this represents the area of our answer. So it would be negative 5, negative 4. We got some more examples that are like that. Only this time we're on the positive side. Maybe we should have done the positive side one first. So we got a number line, and our lowest value is 9. Our greatest value is 14. So let's go ahead and do that. This is 9, 10, 11, 12, 13, and 14. Now we could consider the squares of 81, 100, I think that's 121, 144, 4. 13 squared is that. It's been a little while. Hold on. I know it ends in a 9. 13 squared. 169. That's it. 169. And then, of course, 14 squared is going to give me 196. So we're considering square root of 148. Well, 148 is going to fall right in here someplace, right? 148. So if the square root of 81 is 9, square root of 100 is 10, square root of 121 is 11, square root of 144 is 12, square root of 169 is 13, and square root of 196 is 14, then that means that the square root of 148 is going to fall someplace between the 12 and the 13. So it would be between 12 and 13. Now another way that we could do this is, and it'd probably be a little bit easier, so if you have a calculator, you could always go in, let's clear this out, you could always go into this and take the square root of the number they're giving us, 148, and then hit enter, and it's going to give you a decimal number, 12.1655. So you realize that this is 12 point something, so it's greater than 12, less than 13, so therefore you would realize that it would be someplace between 12 and 13. Well, the next one, complete the following statement. Use integers that are closest to the number in the middle. So we have to use integers as our answer. So those are the numbers going to go in there. So start considering your perfect squares on that. If you go back to your table of perfect squares. So I'm going to try, let's try the square root of, let's go and get the calculator up here. I was going to use my calculator here in my hand, but we'll go ahead and do this. I want to demonstrate, let you see what I'm doing here. So if I go 15 squared, I'm going to get 225. We're not quite up to 336 yet. So let's go 16, and I'm using this button here. It says to square it, right? The x squared. It says take x, whatever you type in, and square it. So I'm going to go ahead and square that. And that's 256. We're still not there, quite there yet. Let's take the next number, 17, and let's square it. 289. We're not to 336 yet. Let's take 18 and square it. 324. Hey, we're getting there, right? And so let's do 19 and square it. And we end up with 361. So 336 falls somewhere between 324 and 361. That means that the square root of 336 is going to fall somewhere between 18 and 19. It's going to be between 18 and 19. Let's look at another one here. Square root of 38. So 38 is low enough. The 336 is high enough. Might want to use a calculator. 38, not so much. Let's see. Think of your perfect squares. 25 is a perfect square, right? 5 squared is 25. And 6 squared is 36. But we're not quite there yet. 38 is greater. So we're going to have to go to 7 squared. So in this case, we're going to have 7 squared is 49. So 38 is going to fall right in between this gap right here. Someplace in between here would be the value of 38, right? 2 more than 36. So with that said, we realize that it's going to be somewhere between 6 and 7. But actually, it's the opposite of. So it's going to be -6 and -7 is what we're considering. And remember, on the opposite end of it, -7 is actually less than -6. So we're going to list it first. And then we're going to list -6 because it's greater than -7. So we're saying that whatever the square root of the opposite of -38, it's going to be some negative number. And if we actually, let's see what that number is. Let's go ahead and, just for the fun of it, let's see what the square root of 38 is. So we're looking for square root 38 equals 6.16. So let's go ahead, 6.16. So we would have -6.16 if we actually solve that. So we know that this value would fall somewhere between -7 and -6. We would read this as -7 is less than the square root of the opposite of -38, and the opposite of -38 is less than -6. So that's how we would read that there. Put that in. All right, what number is closest to square root 51? Now this one's kind of tricky. So we're still going to use the concept of a number line. We're still going to have a number line along here. But first, let's figure out where this would fall. So if we kind of think about between what two numbers would the square root of 51 be? Because 51 is not a perfect square. So we know that 7 times 7 is 49. That's a little bit less than 51. So we know that 7, oh, I'm trying to write with a line. Let me erase that. I know that 7 produces 49. And that means that let's go down here and put in 8. And 8 produces 64. So 51, whereabouts would that fall between these? We don't want to just put it anywhere between there. So 49 to 64 is a jump of, what is that, 15? So right about in the middle here, right? From 49 to 64, 64 minus 49 equals 15. So halfway in between that, what's half 15? That'd be 7.5. So let's just call it 7. We'll just add 7 to it. So we're going to have 7 units over here and 8 units over here. And what number would this be? So if we add 7 to 49, we would get what, 56? And then if we have 7 and halfway between that would be what, 7 units, 3.5 units. Half of 7 is 3.5. So let's go right about here at middle and a little bit over here. And we'll call this here is going to be 3 units, right? So this number here should be 52. So then we have 3 units between there. So let's separate that into 3 units. 1, 2, 3. So this would be 51 right about here. If we did that, let me try to get a smaller eraser. A little bitty eraser, get rid of that 3 there. So we know that 51 sits right here. Now, on the number line, between 49 and 64. Now let's consider the distance between 7 and 8. Well, right smack in the middle, we know it's going to be 0.5, right? And so we're dealing over here. Over here would be 0.75, so you kind of get an idea of what I'm doing here. And then if we split this into quarters, right about halfway right here, this was just half, that's like halfway here, would be 0.25. So we need to go 25 100ths. Half of 25 would be 12.5, so maybe what, 15, something like that, right? Maybe this would be like 0.15 if we work that out there. So we're talking about 7.15 would match up with the 51. And let's look at our answer here. What do we have that's close? 7, 8, well, that would be way down here. 6, 6, that's going to be someplace over there. We know that one's definitely not it. Something in the 6s are definitely not the answer. We know it's between 7 and 8. So we're going to consider our two 7 answers. And it's much closer down here to 7.1 than it is 7.8. So we rule out that one. And our correct answer would be 7.1. Now, chances are most people would do this would be to grab a calculator. And they would go square root 51. Hit enter, and it's 7.14. That was pretty doggone close, wasn't it? 7.15. And I was like 1/100th off. Not too bad of an estimate there. So, indeed, using a calculator would be much easier. Final question here. We're looking for the what's closest, which number is closest to the opposite of the square root of 333. So, I kind of showed how to do the number line. And for the sake of time, because this video has really gotten long, let's go ahead and use the calculator here. And this is getting kind of, we'll clear that out. Let's go ahead and clear the history as well. Outstanding. And so let's just consider the radicand and the radical symbol, kind of not really pay too much attention to the negative sign. We'll deal with that in a moment. So let's do square root of 333. Oh, too many. Let's go ahead and just clear that. 333. Oh, it keeps grabbing. Let's clear that again. 3, 3, 3. There we go. And hit enter. And that's going to give us 18.248. So we'll just call it 18.25. We'll round it up to the hundredths place. And we'll go 18.25. But remember the negative part. So we need to put that negative sign there. So what's closest to negative 18.25? It looks like, don't let this fool you, that's a positive number, and this is a positive number. We're just considering the negatives, and indeed, negative 18.2 is closer to negative 18.25 than the negative 18.7. Right, wow, that's a lot of work, a lot of examples. However, so that is the completion of my presentation for IXL A1.A.6 titled Square Roots. Good luck with your activity.